Hello, good people. In this lesson video, I just want us to solve a complete question, ECZ exam question. That is a 2024 question, 2024 question from paper 2 internal. Okay, so now how can we answer now a complete question from the ECZ past paper? So under Earth geometry. So here's the question. The question came like this. I just wrote it here. The question came as, the diagram shows the point R, Q, P, and T on the surface of the Earth. Take pi to be 3.142 and radius 37 Newton-hours. So now here's the Earth surface, and they're telling us that we have R, P, Q, T, and they have their own longitude and latitude. So the first question is, find the difference in longitude between points Q and T. So this was the first, finding the difference. This was the second lesson from this series. So please make sure that you watch the previous lesson to understand more on how to find the difference. Here we're just going to go straight and calculate and be able to get our answers. So remember, this question is a question that carries 6 marks under Earth geometry. So all these are 2 marks. So let's start with the first one, solutions. Okay, so how do I find the difference between QT? So Roman numeral 1, I want to find the difference between QT. So QT lies, we can see QT lies on longitude 70 degrees west, and T lies on 42 degrees east. So the difference I'm finding is along the lines of longitude, not latitude. So the concept is the same. If they're in the same latitude, we subtract. If they are in the same hemisphere, then we subtract, but different hemisphere we add. So in this case, we have 70 degrees west and 42 degrees east. Now you can see that these are different, the west and east. So because they are different, we add the 2. So which gives us 7, that is going to be 0 plus 2, which is going to be 2, 7 plus 4, 7, 8, 9, 10, 11, okay, which gives us 112 degrees. So we have found the difference between the 2 points, which is 112, and you are done. You see, that is how easy it is. So we move on to the next one, which is calculate in Newton-hours the distance between R and P. So we want to calculate the distance between R and P. So Roman numeral 2, question A, we are finding the distance RP. Now, the distance RP, from my previous video, you notice that this is the distance along the lines of latitude. So the concept should be understood. This is a distance along the lines of latitude. Hence, we are going to use the formula theta over 360 times 2 times radius times pi times cos x degrees. Where x, in this case, it is a latitude they are lying on, and radius, they said in Newton-hours, so radius is 34, 37, and pi we have been given on top there. You can see pi we have been given. So now let's calculate this part. We are going to say RP is going to be, what is my theta? So to find theta, you just have to know the difference between the longitude, between RP, the difference. What is the difference in their longitude? So the difference we already found, which is the same one, which is QT. See the difference of QT, it is the difference of RP. So which is 112. So we just replace there 112 divided by 360 times 2 times, what is my radius? 34, 37 times 3.142 times cos. What is my x in this case? My x in this situation, it is 85. So I just substitute where x is with 85. So this becomes cos 85. Okay, so once you do that, just get your calculator, okay, and punch everything now, which is going to be 112 times 2 times 3437 times 3.142 times cos 85, which gives you 210,828.7042 divided by 360. So on divide by 360, divide by 360, what do you get? We are going to get 585.6352.895 Newton-hours. But remember, they want our answer in 3 significant figures. So this one will just be 1, 2, 3. So it will be 1, 2, 3. It's already in 3 significant figures, but we can see this one. So it will be 5, 8, 5, 8. This one will round it off to 6, 0 Newton-hours. Okay, so we have our answer there and we are done. So once you do this, my dear friends, it means that you are done. You have found your answer. Now remember, there is also another formula. Since they want us to calculate in Newton-hours, you can also use this concept, which is theta times 60 cos x degrees. Okay, instead of using this long method in Newton-hours, you can just use this quick one and find your answer. Find theta is the difference in their longitude, which is only 112 times 60 times cos 85. Just punch that in your calculator and see what you get. So when you punch this in your calculator, you are going to say 112 times 60 times cos 85. And you get your answer. In this case, let's say 112 times 60 times cos 85, which is going to be 5, okay, the same as the other one, 585.6, okay, 0.68865913 Newton-hours. But to 3 significant figures, this is the same as 5860 Newton-hours. So this and this, they are just one and the same, but we are using different method. You can see we use the first one, we got this one, and the second one, we get this one. So you can use any method here, you will get your answer straightforward. Now let's move on to the next one. The next one is asking us to calculate the distance PT. So we need to calculate the distance in this question, PT. So how do I calculate this distance, PT? So you can see PT is along the lines of longitude. So what is the formula that you need to know? So the distance along the longitude, PT, we are going to say PT is actually theta over 360 times, times 2 times radius times cos, times radius and times pi only. Okay, or we can use the formula, which is straightforward. In this case, it will just be PT is equal to, same as, don't mind this bar, PT is same as theta times 60, okay? Theta times 60 when you are calculating in Newton-hours. So the question is in Newton-hours, so let's just get to know what my theta is. What is theta here? So if it is in the latitude, say this is a distance along the lines of longitude. So we are finding the difference in the latitude. So our theta is the difference between this latitude and this latitude. So the difference will be, now let's find the difference. So we are going to say PT, the difference. We want to find PT here. So the difference between PT, we have 85 degrees north and 20 degrees north. Now, if we said if they are in the same hemisphere, you see this one is north, so they are in the same hemisphere, so we just subtract. So it will be 5 minus 0, which is 5. Then what is 8 minus 2, which gives us 6, okay, which gives us 6, okay, degrees. So our difference between PT is 65. So this is our theta now. So theta is equal to 65. Hence, we just come here and just write 65 times 60. Punch your calculator. What do you get? 65 times 60. We are going to get 3,000 or 300. Okay, 3,900 Newton-hours. And you are done. Okay. So this is a straightaway method. you use this one because the answer is nautical miles, so you can use this formula instead of wasting a lot of time with this one. Use this one. If you want, you can use this one. You still find this answer. There is no difference. So this is how you were supposed to answer 2024 paper 2 internal. Okay, question number 7B. So this is how you work it out. So with this now explanation, I expect you to be able to understand all our lesson videos to this lesson number 5. Okay, so if you have not watched my previous lesson videos, please do watch so that you understand Earth geometry in full. Don't miss the next lesson video because we are going to be talking about how to calculate now speed. Okay, how to calculate speed and also the radius of the Earth. How can you calculate the radius of the Earth and speed? So don't miss the next lesson video. If you are not subscribed, do subscribe so that you get to understand more and learn more of this kind of mathematics concept so that you don't fail your exam. Remember, only via practice makes mathematics easier. Subscribe to this YouTube channel and you are going to be blessed as I post more new latest videos. Bye bye for now.